So when you're doing anti-differentiation, there is no product rule or quotient rule for anti-differentiation. The process you go through for anti-differentiation is basically find ways to rewrite the integrand so that it looks like something that you know how to take the antiderivative of. Okay, so in this case, I do have a sum of power functions divided by a power function. There is no quotient rule for antiderivatives. I cannot deal with this as a quotient. So the best way that I can deal with this is to see if I can rewrite it as some function that I know how to take an antiderivative of. And the one operation that antiderivatives, or two operations, I guess, that antiderivatives do respect is sums and scalar multiples. Because it's sums and scalar multiples, this also covers differences. Okay, so if I can rewrite this as a sum or difference of functions that I know how to take antiderivatives of, then that will help. So the way that I'm going to do this in this case is basically see in the denominator, I have a single power function. And so I can divide each of those terms by that power function. Okay, so I am going to rewrite this function as a bunch of power functions. So I have 4 times x to the 7th minus 3 times x to the 1/2 plus x to the 1/3 power. And I'm going to divide this whole thing by x to the 3/2 power. And I have my dx out there. So now power functions, the powers subtract when I divide them. So this is the same as the integral of 4 times x to the 7 is the same as 14 halves. So 14 halves minus 3 halves is 11 halves minus 3 times x to the minus 2 halves is minus 1. Plus x to the, I have to do this off to the side, 1/3 is the same as 2/6. And 3/2 is the same as 9/6. So it'd be -7/6. Okay, so now I am finding the antiderivative of 3 different power functions. Okay, so I can see this as 4 times the integral of x to the 11/2 dx minus 3 times the integral of x to the -1 dx plus integral of x to the -7/6 dx. Okay, so here's 3 power functions. And so you can use the power rule for these with one little caution. So power rule says you increase the power by 1 and then divide by that power. So this is 4 times x to the 11/2 becomes x to the 13/2. And I'm going to divide by that 13/2 or multiply by its reciprocal 2/13. Minus 3 times x to the -1. If you try to use the power rule on this, it is x to the 0, which is a constant, and there's no non-zero function which anti-differentiates to a constant, right? So this is actually, this should ping your concerns about this being wrong. And this is actually where this is the one power that you can't do using that power rule. you will use the integral of 1 over x dx that's a natural log of absolute value of x. Okay, so that is one that you actually need to commit to memory and just like, you know, and keep it in your brain. So this is going to be -3 times the natural log of the absolute value of x. And then that last one is I am going to increase the power by 1, which is going to be x to the -1/6. And then I'm going to multiply by the reciprocal, divide by -1/6, or multiply by -6. So I'm just going to say this is going to be -6. And then I have plus a constant. Of course, I don't have to add a constant to each term when I'm doing this, like, because those all gather up to be one big constant. So I'm going to simplify this now. This is going to be 8/13 times x to the 13 halves minus 3 times the natural log of absolute value of x minus, we can do 6 over the 6th root of x, or I kind of like power functions at this point, 6x to the -1/6 plus a constant. And it is worth taking the time to check this answer by differentiating, taking the derivative of your result and making sure that you actually end up with, basically you would make sure that you end up with this modified version of the original function that you started with.